Okay, this is my second video on similar triangles. Let's go on a little bit of a thought experiment. Let's not start with a triangle. Let's start with a square. And let's just say that the length of each side is 1 centimeter, 1 centimeter. So that's my square there. And I'm going to now draw a square that it's supposedly double the size. Okay, so this is going to be 2 centimeters and 2 centimeters. Now these squares are similar, obviously, because if you look at the ratio, it's going to be a 1:2 ratio, and that's because this square is double the size of that one. Okay, you can also say that the scale factor, if I take one side of the bigger square, 2, divided by one side of a smaller square or a corresponding side, the scale factor is 2, saying that the bigger square is 2 times the size of the smaller one. Okay, cool. So that's our preamble. Let's find the area of the two squares. So the area of the little square is going to be 1 times 1, which is going to give us 1 centimeter square. The area of the bigger square is going to be 2 times 2, which is going to give us 4 centimeters square. Now, a typical question that you might get in an exam is that they might give you the area of a smaller triangle and say that a similar triangle is twice the size or of the smaller one, and they want you to work out the area without actually drawing the bigger triangle. Well, let's have a look at the ratio here between the two. The ratio between the bigger and smaller square, well, the area ratio is a 1:4 ratio, because area of the small square is 1, the area of the big square is 4. Now, if you think of it very carefully, you're going to see that before, when we were just looking at the length of the sides, the ratio was a 1:2 ratio, but now the area is a 1:4 ratio. It also means that the scale factor, which I'll write down here, the scale factor is going to be 4. Well, long story short, is simply this. If you ever want to find out what the area of the bigger shape is, so long as you know what the scale factor is, you square the scale factor. So I'm going to write scale factor square, and then you multiply that by your old area, or the smaller shape, old area, to get the area of your bigger shape. So for example, since I know the scale factor is 2 on my between the size of the two similar shapes, if I square 2, I will get 2 square is 4. I multiply that by the old area, which is 1, and so I know the area of the bigger shape is going to be 4, because 2 square gives me 4, and I multiply it there. Alright, let's carry on along this line for just a second. So now I'm going to say that I have a triangle, and the area of this triangle is 5 centimeters square, and I want to know the area of a bigger triangle that is 3 times the size of my smaller triangle. Okay, so remember, my bigger triangle is 3 times the size of my smaller triangle. Well, think about it. If it's 3 times the size of my smaller triangle, then it means that my ratio is a 1:3 ratio. Okay, which means that my scale factor is 3. Okay, so I prefer to go from the scale factor point of view. My scale factor is 3. Okay, my scale factor between the two triangles. Okay, now if you follow the rule I just gave you, if I want to know the area of the bigger triangle, I square my scale factor, so 3 square, and I multiply that by the area of the smaller triangle, which is now going to give me 9 times 5, and that's going to give me 45 centimeter square. And it's as simple as that. That is pretty much done. So memo to self, remember, square the scale factor multiplied by the old area. Obviously, if you've got the bigger area, let's just say you were already given the 45 and you needed to work your way back to the smaller, you just do the opposite. Rather than multiply by 3 square, you would have been dividing by 3 square, okay? Okay, let's move on. Here we have another thought experiment. So, let's talk a little bit about volume then. So I'm going to go back to my drawing, but this time I'm going to use a cube. And I'm going to say the length of all the sides on the cube is 1 centimeter. So that's 1 centimeter, 1 centimeter, 1 centimeter there. Okay, and I'm going to say I've got a cube double the size of the little one. Okay, so you can see where this is going where this is going now. So each side will be 2 centimeters, 2 centimeters, and 2 centimeters there. Well, let's find the volume. The volume of my little cube will be 1 times 1 times 1, which will be 1 centimeter cube. The volume of my bigger cube now would be 2 times 2 times 2. Just a gentle reminder that volume will be area of the base multiplied by the uniform height. So the base is 1 times 1, which is 1, and you multiply it by the uniform height, which is also 1. So the same thing here, area of the base, which is 2 times 2, and then you multiply it by the uniform height, which is also 2. Anyway, let's finish this off. This gives us an answer of 8, because we will say 2 times 2 is 4, and 4 times 2 is 8. So 8 centimeter cube. Well, let's look for a link. So the link is, when you were just looking at the length, you would have had a 1 to 2 ratio for the length. Okay? And or a scale factor of 2. So I should probably write that down as well. A scale factor of the length would be 2, because it means that this shape is double the size of that one. Okay, now let's look at the ratio. Well, for the the ratio for the volume, we've got 1, we've got 8, so it's a 1 to 8 ratio for the volume. Or if you want to go down the scale factor route, the scale factor is 8. Well, how do they all link with each other? Well, think about it this way. The volume for the volume now, if you take the scale factor, so the volume, this is your volume change, I'll call it. You take the scale factor, which was 2 to begin with the length, and you cube it, and then you multiply it by the old volume. Okay, so that now means it's going to be 8 times whatever the old volume is. Okay, and that's pretty much it, and you work it out exactly the same way as the area. Let's look at an example. Okay, so here's our example, and I'll talk you through it quickly. So here I'm gonna assume, well, I've got, I don't know, 2 slabs of concrete, say, and this is my first little slab, and that's my big slab here. the volume of this slab is 18 cubic centimeters. And we want to know what's the volume of this slab, okay, which is bigger. Now, before we even try doing anything, try to look at what information you've been given. So here, you've been given the length of this side is 3, and the corresponding side of that is 12. So what I would want to know is what's my scale factor? By how much did the shape increase? So my scale factor, I will take my bigger shape divided by my smaller shape, and I realize that it's increased by 4. So it means that this shape is 4 times the size of that shape. Since it's the volume that I'm doing, I can now say that therefore the volume of my bigger shape is going to be the scale factor cubed, and then I multiply that by the volume of the smaller shape, which will give me 1152 cubic centimeters. Okay, and that's basically it. The most that you can have is a more sort of complicated problem where things aren't really that easy to see, but then it works out in the same way. Let's look at an example. Okay, so here we go. Now, of my two triangles, I've got this side is 6 and that side is 9. Let's just say, let's do an area and a volume one after. So we're going to say that the area of this little triangle is, for the sake of argument, 20 centimeters, okay? Just so that we know that the height is not really something we can play with. Okay, 20 centimeters. And we might want to then find out what the area of the bigger triangle would be. Well, let's look at the scale factor first. And the scale factor would be the big triangle, 9, divided by a smaller triangle, 6. We can simplify that down into 3/2. So basically what we're saying is that the bigger triangle is 1.5 times the size of the smaller triangle. So that's fine. So the area then of your big triangle, area, is going to be equal to your scale factor, square for area, multiplied by the area of your smaller triangle, which is going to be equal to 45 centimeters square. Okay, and that's pretty much it. I can do the same thing. Let's just say this was some sort of a triangular prism. Okay, so I might just give this a little bit of depth there. And we've got a similar prism going along there. Okay, and we might be doing the same thing for the volume. So I might say that the volume of the smaller one is equal to, I don't know, let's call it 60 centimeter cubed. So if I want to find the volume then of the bigger one, it's going to be the same thing, 3/2, because that's my scale factor cubed, times by that 60 centimeter cube, which will now give me 202.5 centimeter cube. Okay, so that's basically it, guys. I mean, the worst it's going to get is where they've already given you the two volumes or something like that. They might actually tell you if it's bigger by how much bigger it is, and then they might ask you to find the length of some missing side or something like that. Same sort of procedures that you will use, but this time you'll just work backward. Right, so I hope this was helpful enough. If you want to see problems like that, I mean, just let me know and then I'll find some and do them for you. All right then,